Okay, so in this video, uh, we'll understand the concepts of point set topology, right? So let's begin with, yeah, see, one dimensional real line and two dimensional plane, okay? And then let's begin with the neighborhood of a point, neighborhood of a point, okay? Or also called the delta neighborhood of A, right? Yeah, so let's try and understand what this is first for the real line. Okay, so this is our real line, and this is a point A on it, right? And simultaneously, this is our plane, right? And here's the point A. Now we know, okay, let's come back to this. Now we know that there are infinite points on the real line as well as everywhere in this plane, right? Infinite points. Okay. So, what do we mean by neighborhood of a point? Okay. I'll stick to the one dimensional line now. Okay. So, delta. What is delta? Delta is a number, a real number, greater than zero. That's it. Infinitesimally small, as they call it. So it is smaller than the smallest number you can think of. And what we do is, from the point A, we move left and right. How much we move? We move a distance of delta on both sides. Okay, that means if A is the point, then A minus delta and A plus delta. We shifted delta units this side and delta units this side. And then we formed this interval. Okay, so interval contains an interval on a real line contains all the points lying on this. Like this is an open interval, we'll discuss it. So it contains, wait, it contains all the points except the points that are on the extremes. Okay, so all the points inside this except the points on the extreme, except these ones. Okay, so this is delta neighborhood of A. Delta can be as small as you can imagine, even smaller than that. Okay, so what we are implying is we take a point and then we look around it, extremely small, both sides. That is called the delta neighborhood of A on a real line. And what about the two dimensional plane? Well, same thing. Delta neighborhood of A means we form a circle of radius delta with point A as the center. This is the delta neighborhood of A. And now, about delta being smaller than you can imagine, we just keep decreasing the size of delta. So it will keep, you know, it will keep, like if this is point A and we keep reducing the size of delta, it will keep closing in from all sides on A, right? So our delta neighborhood will be smaller than this, even smaller than what I have made. Okay, infinitesimally small. extremely small disk around this point. Okay, so that is the delta neighborhood of A in 2 dimensions, right? In 3 dimensions, it's a spherical ball. But let's keep it out of our context as of now. Okay, so now that we know about the neighborhood, yeah, let's let's understand what we discussed here. Open interval. Yeah, let's start with that. Open interval and open set. Okay. Now, before this, we need to understand what is an interior point. Interior point. Okay. Interior point of a set. Now, set can have points, discrete points, continuous intervals. Set can have two tuples in R2, three tuples in R3. Okay, so set is a general term. Interior point is a general term. Okay, so what is an interior point? Interior point means a point, like if this is our set, then a point in the set whose delta neighborhood is entirely contained in the set. That is called an interior point. Okay, suppose this is the real line and this is a point. This is our set. It is an open interval. Okay, we'll get to this also, don't worry. Open interval, open set, we'll get to it. Okay, first understand interior point. You take any point on this, any point. Okay, no matter where, take any point, but its delta neighborhood, its entire neighborhood, any point here. Okay, it's too light. So look, focus here first. Any point, let's zoom in. Let me zoom in this portion. See, this is okay. So take any point as close to this as you can, but its entire neighborhood should lie inside this set. Okay, and here comes the concept of deleted neighborhood. You see, a point is so small that you cannot just mark it. You cannot mark it on the real line. A point is extremely small, no matter if it is 1 or if it is 0.00000001. No matter what the point is, it will take the same space on the real line. Okay? And when you remove that point, you will be left with all the points around it in the neighborhood except that point. This is called the deleted neighborhood of that point. Okay, now why is this concept important? Yeah, see, here in this case, what if we take this point on the extreme? Now let's zoom in again then. Okay, this is the real line and this is the point we are talking about. Extreme, on the extreme end of the set, which is an interval in this case. Okay, its neighborhood. Now its neighborhood will cover delta distance in this direction and delta distance in this direction, right? Now this direction is all right, but what about delta distance in this direction? All the points from this point till the boundary, extreme, okay, they will be outside the set, not inside the set, because the set only contains the points which are here on this side. Okay, not on the other side of this line. So if I take a delta neighborhood, no matter how small I squeeze it in, the points on this side will always be outside this set. Okay, so this extreme point is not an interior point, right? Similarly, in the two-dimensional plane, any point, any point, and its delta neighborhood should, if it lies entirely inside the set, that point is called an interior point, right? So points on the extreme, on the circumference, if it is a disk, points on the circumference, some of their points, some of the points in their neighborhood will lie outside the set. So the points on the extreme are not interior points. Okay? But the points just next to this, to the extreme points, no matter how close they are to this boundary, no matter how close they are to this boundary, their neighborhood, entire neighborhood will lie inside the set. Okay? I hope the definition of interior point is clear. Okay? So the point whose entire neighborhood lies inside the set is an interior point. Similarly, a point whose entire neighborhood lies outside the set is an exterior point. Okay? So a point outside the set, a point whose entire neighborhood is outside the set, entire delta neighborhood outside the set, that will be an exterior point. Okay? So I hope it is pretty obvious that the points lying on the extreme edges, on the boundary, so-called boundary, half of their neighborhood, or not exactly half, but some of their neighborhood would lie inside the set and some of it would lie outside the set. So such points can neither be called interior points nor can they be called exterior points, right? So what are they called? They are called frontier points. Frontier points. Okay? So, like on the real line, if I make it this side, then this point, this exact point, its neighborhood, neither is it entirely inside the set, nor is it entirely outside the set. So this is a frontier point. Okay? So interior point, entire neighborhood inside the set. Exterior point, entire neighborhood outside the set. Frontier point, half of the neighborhood, not half, I mean some of the neighborhood inside the set and some of the neighborhood outside the set. So frontier is basically neither interior nor exterior. Okay. Now, okay, open set or interval. And okay, first let's do it side by side. Open set and closed set. Okay, and closed set. Now open set is when, okay, let's write it mathematically. For all A belonging to the set, when delta neighborhood of A is contained in the set. Now delta neighborhood A will be a set, so it will be contained in the set. Then it will be an open set. Okay. Let's see this visually. Suppose this is an open set. Okay. From A, no, not A, from P to Q, right? Now, this point P, we know that in an open interval, P and Q will not be included in the set. So P does not belong to the set S and Q does not belong to the set S, right? So what makes this an open set? These P and Q were the only points, some of whose neighborhood, delta neighborhood, was outside the set. Otherwise, any point to the right of P and any point to the left of Q, any point you take as close to P and Q as possible, their entire neighborhood, delta neighborhood, would be a part of the set. Okay? So, when every point of the set is an interior point, that means when delta neighborhood of every point of set is inside the set, then it is an open set. Right? Slow it down, listen to it again, visualize it. It is very simple, honestly. Okay? Open set, this was on the real line, and in 2 dimensions, we can make a dotted bound, like, yeah, dotted boundary. Okay, so this is how we represent an open set in 2 dimensions. Okay, so any point inside this, the point on the circumference, let me call it circumference for a while, it can be any vague shape. Set can be represented as anything. Okay, looks like a tooth. Anyway, so it should not lie on the boundary. Okay, it is boundary, don't confuse it with the boundary points. So any point lying within this boundary, no matter how close to the boundary, any point within the boundary, no matter how close to the boundary, its entire neighborhood will be contained in the set. It will not go outside the set. This means that every point belonging to this set is an interior point. And that is when this set will be called an open set. Right? Fairly simple. Now, closed set. Closed set is real line, closed set. Now, these are our points P and Q. Okay? Yeah. Yeah. One thing, one definition of closed set is when the complement of set is open. Okay? What does that mean? Okay, let me clear this. Open set. Yeah, you can revisit it anytime. Closed set. Okay, one definition of closed set is if S is the closed set, then S complement is open. What does that mean? S complement means points that lie here, here, as close to P, as close to P as possible, as close to Q as possible. Their entire neighborhood would be in S complement, right? It would lie outside the set. Any point, no matter how close to P, no matter how close to Q, its entire neighborhood will lie outside the set. This implies that S complement is open because delta neighborhood of all the points in S complement lie inside the set S complement. Right? Again, slow the video, listen to me again and again. It is fairly simple. If you are confused, it is fairly simple. Okay, just visualize it. Okay, similarly, in an open disk, sorry, closed disk, same thing. This is the set S. You take any point as close to this circumference as possible, any point as close to it as possible. Its entire neighborhood will lie outside the set. That means it will lie in S complement. That means it is an interior point of S complement. Why? Because its entire delta neighborhood is in S complement, which implies S complement is open, which implies S is closed. Okay? And now comes a different definition. This video is going to be very long. I'm sorry for that, but I think it is necessary. So let's understand the limit points now. Okay, or also called accumulation points. Okay, limit points are any point whose neighborhood contains infinite elements of the set. Any point whose neighborhood contains infinite elements of the set is called a limit point. On your real line, I'm making an open interval PQ where P and Q do not belong to this set I have taken. Let's take this set as X. Okay, they do not belong to the set. It is an open interval, right? But what about these points P and Q? Well, we remember their delta neighborhood, which is supposed to be this. It is neither entirely inside the set X nor entirely outside the set X. So P and Q are neither the interior points nor the exterior points. They are boundary points, they are frontier points. Also, they are limit points. Why? Because from this side and from this side, their neighborhood contains infinite elements of the set X. Yeah, I hope I make sense, right? Any piece of real line will have infinite elements. I hope you know this. Yeah, you would know. Okay. So P and Q are limit points. The set of limit points is called, I think, derived set. Yeah, it is called the derived set S dash, not to be confused with this S. Okay. Okay. The set of limit points is called the derived set. Okay, so derived set of this open interval PQ will be closed interval PQ because P and Q will also be limit points. Okay, similarly, in this case, right, all the points lying on the circumference, they are limit points because their delta neighborhood from this side contains infinite elements belonging to the set we're talking about. Okay, so say if this point is A, then A is a limit point. In fact, all the points lying on the circumference And obviously, all the points inside the set also, they are limit points because their neighborhood contains infinite elements from the set we are talking about. Okay, I hope this is clear. So, another definition of closed sets is when all the limit points belong to the set. See, in this case, P is a limit point, Q is a limit point. Okay, neither interior nor exterior, but it is a limit point. Okay, so another definition of closed set is that when all the limit points belong to the set, then that set will be closed. Okay, I think, yeah, one more thing is left. Closure of a set. Okay, like this was derived set. Okay, closure is represented as S bar. Derived set is represented as S dash. Now, what is the closure of a set? It is a set of all points whose neighborhood contains even a single element from the set. So, if the neighborhood contains even a single element of a set, then it will be a part of the closure of that set. Okay? Yeah, I think that is all. Then there are, okay, yeah, this one thing, S interior, set of interior points. Okay, simple. Set of interior points. Closure of a set is the set of all points, I'm repeating, whose neighborhood has the intersection of whose neighborhood and set. Any point, intersection of whose neighborhood and the set is not empty. That is included in the closure of a set, right? Yeah, I think that is all. There is dense set, compact set, connected set. Okay, I think I'll make it another video about this. Like if someone watches this and they feel the need, then just write in the comments and I'll make it, okay? So now I'm saying again, this concept is very simple, very, very simple. If you are finding it hard to understand, watch the video again. Ask me in the comments, okay? Good luck.